Hello students, welcome back. So now I'll show you how to perform A/B testing for a new website. Suppose an e-commerce company, they create a website and this website has a chatbot. So they have two versions. The version A, that is your control website. This is your old website. This is the one without the chatbot. Then you have a new one, which is a version B. This is your new website. This is the one that contains the chatbot. So the goal is this: you want to check, does it increase your purchase conversion rate? That's what you want to check. So the steps we will be following would be like this. The user, he visits the website, he randomly sees website A or B. A is the one without the chat part and the B is the one with the chat part. Some users, they purchase and we compute the conversion rate, how many people purchase and how many people did not purchase the product. And then we are going to use z-test check significance, and then we are going to make our decision, the product decision. We're going to decide, should we keep the website A or website B. So the first thing I'm doing, importing my necessary libraries, importing NumPy, and I'm also importing stats model library. If you do not have this library, go ahead and install this library. So now we run the experiment. In our case, we are going to be generating the data. So let's say you have 8,000 users and your old website A, the conversion rate, let's say, is 8%. So my control rate is 8%. I'm just putting these numbers out there. In real world, you will be actually determining these numbers. I'll show you now how to later on how to determine these. Then in new website B, let's say the conversion rate is 9.5%. That's just slightly better. So the treatment rate is 0.095. So I want to generate a data based on these two parameters. So if the user comes to your website, if he makes a purchase, it's going to be 1. If he does not make the purchase, I want it to be 0. So I'm creating a list that an array, sorry, that is your control. This is going to contain 0 and 1. So 0 means he did not make a purchase and 1 would mean he made a purchase. So this particular inbuilt method, it actually generates this data for me. And likewise, I'm generating another data for B right here. The treatment data, this is for website B. So I print out the data right here for with the chatbot. Sorry, without the chatbot, that's my A website, and the website B, the one with the chatbot, I'm printing out the data for this. So you can see that for A, this is my data, and for B, this is my data. What this 0 means right here for A, if a user comes over here to website A without the chatbot, so this user, he did not buy the product. This user bought the product, did not buy the product, did not buy the product. So this what 0 and 1 means. On the B website, the data is this right here. This is guy did not buy the product on when he visited the website B with the chatbot, did not buy the product, did not buy the product, and he bought the product. And now I'm going to calculate the conversion using the data. So the first thing I'm doing, I'm actually focusing on samples. I want to see how many total samples I have. I'm using the len function. So this is going to give me how many people they came to website A. So this particular one right here is going to give me the total samples for website A. This one right here, it gives me the total samples for website B. In other words, how many people came to website B. Now, after people they came to website A and B, I want to calculate how many of them bought a product. So this one gives me the successes. Okay, how many people bought the product for website A? Treatment.sum. This is going to tell me how many people bought the product for website B after they went to website B. So that's what I'm doing. I'm just adding all the ones over here. I'm adding all the ones, and then I'm printing out my samples and successes. So this 8,000, well, that would be this number right here, is telling me 8,000 people they visited website A. This 8,000 is telling me that 8,000 people visited website B. 635 people, that would be this number right here, they actually bought the product after they visited website A. This number right here, 743, that would be this right here. This tells me that 743 people, after they visited the website B, they bought the product. Now let's calculate our conversion A. So in this case, all you're doing, you're taking this number. For you taking 635, you divide by 8,000. This is exactly what I'm doing over here, and that's going to give me my conversion rate for website A. That is my old website. Then you take 743, divide by 8,000. This is exactly what I'm doing over here. This is going to give me the conversion for website B, and the answer comes out to be this right here. So this is not surprising. This is exactly the same, almost pretty much the same as the one that I just showed you. That was this number right here, this one. And because this one actually I generated these numbers, that's why it's coming out to like this. In real world, you will be actually running this experiment, and the numbers would be, you would have to calculate your number, whatever this number comes out to be. All right, so I got these numbers. This is my old website without the chat part. That means 7.9% they made. That was the conversion rate, and the new website with the chat part, the conversion rate is 9.29%. And now we define our hypothesis. So let probability of A, it means the probability that a user purchases using the old website, the website A. And let's say probability of B, that is the probability that a user purchases using after visiting a new website, that is your website B. So you will have two hypotheses, null and alternative. Null hypothesis means no change, everything remains the same. The probability or a chance of a user purchasing is same with or without the chat part. So the chat part doesn't make a difference. That's your null hypothesis. Alternate hypothesis means that there is an improvement. The probability or chance of a user purchasing is more when you put the chat part on your website. So I'm printing this H0 H1 out. H0 means no change, new website performs the same. So probability of B equal to probability of A. H1, that's your that's your alternate hypothesis. In other words, your new website, it improves the conversion. So the probability of B is more than the probability of A. So that's all I'm doing over here. And now we use proportion z-test. So why do we use proportion z-test? Well, that's because we are comparing two probabilities. In other words, two proportion. That's coming from a binary outcome. Binary outcome in this case is 0 and 1. 0 means you did not buy the product, the user did not buy the product. 1 means the user bought the product. And in this case, we have a large sample size. So we want to know, is the purchase probability different between the two groups? In other words, is the probability that a user buys the product, is it different when he visits the website A versus the website B? So your probability of A, there is the purchase probability with the old website, that is your A right there, and we are comparing versus the probability of B, the purchase probability with the new website. So because we are comparing these two proportion, okay, so we must compare these two proportion. That's why we use proportion z-test. So in this case, I'm calling this inbuilt method proportion z-test. This is part of your stats model. Count equal to success. Number of observation, that's your samples. You supply your parameter, and that's going to give you your z statistics and p value. This is the most important, your p value. I got my p value from here. Then I make a decision. So I'm choosing my alpha 0.05, make a decision. So if my p value is smaller than alpha, I'm going to reject H0. This is how these hypotheses they work. So in this case, I'm going to launch the new website. When I run this, it gives me decision fail to reject H0. Well, that's because my p-value, if you look at the way p-value is 0.99883, and this is my alpha. So in this particular case, it is going to fail to reject because this condition, your p-value is not smaller than alpha. It is bigger than alpha. So fail to reject H0. That means keep your old website. The chat part did not help over here.